Alright, welcome. This is the 7.3 Ready Set Go homework solutions. Alright, the ready part. It says the given figures are to be used as a pre-image. Perform the stated transformation to obtain an image. Label the corresponding parts of the image in accordance with the pre-image. That means to just label the vertices. Alright, so you have this image here. I label it A, B, C. A is -7, -5. B is -7, -1. And C is -9, -2. Alright, it says for the first one to reflect the triangle ABC over the line y equals to x and label the image as A prime, B prime, and C prime. The line here, down here, is going to be your line of reflection. That is y equals to x. Notice that this is actually a linear equation. The slope is 1 over 1. That's why you go up 1, across 1. The y-intercept is 0. So if you reflect the triangle ABC over the line y equals to x and label the image as A prime, B prime, and C prime. Notice this equation means just to change the y with the x. Originally, the one right here was -7 and the y was -1. It flip-flops. The new b prime is -1, -7. Likewise, the a from before was -7, -5. It flip-flops. It becomes -5, -7. Okay, and the other one is before -9, -2. It became -2, -9. All right, that's what happens after you reflect it. Next, okay. You want to rotate the triangle A prime, B prime, C prime 100 degrees clockwise around the origin and label the new image A double prime, B double prime, and C double prime. Here, it's in the third coordinate where it's negative, negative. If you ever rotate it 180 degrees, it goes here where it's just become positive, positive. Right? So that means all these values here from A prime, B prime, and C prime, you get the double primes by just going from negative to positive, right? It was -5, -7 became +5, 7. Likewise for B prime to B double prime, C prime to C double prime, right? It all became positive. Good. All right, the next one, 2, it is to just reflect over the line y equals to -x. Okay, I label the points again here. A was 2, 3, B was 4, 2, and C is 5, 5. There you go. You want to reflect it, y equals to -x. -x is the same thing like before, but the slope is negative, so it goes downwards. When you reflect it, notice both the x and the y became negative after the transformation, because that is what y equals to -x does. Okay? Right? It flip-flops. Before it was 3, now it becomes -3. It was 2, it becomes -2. Likewise, this becomes, before it was 2, it becomes -2. 4 was for the x, it becomes the y as -4. C, 5 becomes -5, and C is also -5. Okay, so C is -5, -5. This is how it looks like after the reflection. Good. Next one, you want to reflect over the x-axis, then rotate 90 degrees around P. The blue shape here is how it looks like after the reflection. That reflection is occurring over this line of reflection, which is the y-axis. Notice that when I rotate it 90 degrees, okay, the green is applying the perpendicular slope for the rotation of 90 degree clockwise. Okay, so before it was up 1, 2, 3, right? Or you could also say like down 3 across 1, right? If you flip it, it becomes up 1 across 3, right? Then I fill it in. So I apply the perpendicular slope to get how the coordinate should look like at the 90 degrees clockwise rotation. Here you go. That's how it looks like. Alright, let's look at number 4. Okay, you're going to reflect the quadrilateral ABC over the line y equals to 2 plus x and label the image as A prime, B prime, C prime, and D prime. Right here, I label it. That is your y equals to 2 plus x. In reality, you want to write it as y equals to x plus 2. That means the slope is 1 over 1 and the y-intercept is 2. Good. When you do reflection, reflection just means it's equidistant. So, right here, this D to the line of reflection had a distance, I think, of 2.5. So it flip-flops right there. Same thing with C. It was 2, a distance of 2 units. This is a distance of 2 units. A, right, that distance unit is mirrored identically. Then you connect the dots. That's how I get A prime, B prime, C prime, and D prime. Good? Because understand reflection is the same distance. Next, right here, it is the rotate the quadrilateral. A prime, B prime, C prime, and D prime counterclockwise 90 degrees around the point -2, -3 as the center of rotation, and label the image as A double prime, B double prime, C double prime, and D double prime. Here I have my original image. That red dot here stands for the center of rotation, which is at -2, 3. Right? Again, to do my rotation of 90 degrees, I'm just applying perpendicular slope. The red one is the slope of the original from the axis of rotation to the point C prime. Could I use D prime? Sure. Could I have used A prime? Sure. I just used C prime because it made a really neat triangle. Okay? It was up 2 across 3. So I do the inverse of that, right? The opposite reciprocal. So that became up 3 across 2. Good? That's how I got this point C prime. Right? Again, I apply the right triangle. I can rotate the triangle, or I do the perpendicular slope. Okay? Gets me. Then I connect the dots. I do that to the rest, and I get the dots here. Good? Again, for rotation, you have to apply the perpendicular slope. Alright, let's do the set part here. Alright, it says to find a sequence of transformations that will carry RST onto the triangle R prime, S prime, and T prime. Clearly describe the sequence of the transformations below each grid. Here's the first one. That is the original one. Then use the blue. Okay, I'm going to reflect RST over the this should be -7 over x equals to -7. Okay, or that's the line RS. Then you want to rotate it about rotate it 90 degrees on the point -5, 2, -5, -2. That is the point for, I think, S. That was S right here. Okay, that's how I rotated. I kept it around that point. Good. Then the reason why I rotate it so it looks like the top triangle, then I just translate it by going up 3, then across 1. Perfectly done right there. Okay, so I reflected, rotated, then translated. For you, some of you could have done it differently. Okay, next one. I have the original image. I'm going from here, RST to the prime. So first thing is I translated x minus 8, which is going to the left. Okay, nothing happened to the y. Then I reflected over y equals to 2, which is this horizontal line right there. Gets me that image right there. Here's the go part. Right, goes the review of the systems of equations. Okay, you have graph each pair of functions and make an observation about how the function compare to each other. Okay, very straightforward. Look, the intersection is at 0, -1. These are perpendicular slopes. That's why the lines are perpendicular. They should form a 90 degrees. Okay, or you could say they're 90-degree rotations of each other. Next, this is also perpendicular slope because the original is -2, 3. Flip it, then change the sign. It becomes 3 over 2. This is also perpendicular slope. They form 90 degrees as well as they are 90 degrees rotation of each other. Next, this one, 1 over 4 and -1 over 4. Look, this is, they're almost vertical angles. Okay, you would say this is a reflection over the y-axis. Alright, you could get, that's an interesting way of proving vertical angles. Nice. Alright, reflecting it over the y-axis. And this one, I think I graphed this wrong. It should curved. Sorry about this one. This one is also going to be looks like that is a reflection over the x-axis. Okay, 10 was an error. Okay, it should have curved. I graphed it wrong. All right, so there you go. Those look like those are all your solutions for the Ready Set Go for 7.3. Please understand that the number 10 here is wrong. Okay? All right, those are all your solutions. There you go.